Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. For tonight, we're going to take a look at some exciting coding activities for STEM courses and STEM camps. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the poll on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to introduce our two panelists for tonight, Mark Garneau and Todd Graba. Mark is a helping teacher for the Surrey School District in British Columbia, supporting teachers for mathematics and numeracy K-12. A T-Cubed national instructor, Mark has been involved for many years as a tech author for many of the math-inspired activities, in which capacity he has developed many of the tips and tricks for creating interactive documents. In addition to promoting the effective use of technology in mathematics, Mark also focuses many of his workshops on teaching through problem solving, formative assessment, and the power of visualization for developing concepts. He is currently the Canadian Regional Director on the NCSM board. Mark, thanks so much for being with us.
Thank you very much, Michael, and it's great to see a huge crowd tonight. I'm looking forward to it.
And Todd is the STEM Division Leader at Crystal Lake South High School in Crystal Lake, Illinois. His teaching background is in physics and chemistry, but has extensive curriculum experiences in all high school math and science practices. Todd's main professional development areas for Texas Instruments are in using the TI-Nspire and TI Navigator systems in science classes, and with incorporating coding into the classroom or STEM activities with the TI-Innovator Hub. Thanks so much for being with us, Todd.
Mike, thank you, and welcome to everyone from around the world as I'm seeing people chime in here. Hopefully we make this hour a good one for you and leave some powerful information to bring back to your classes.
We're expecting a large crowd, so your audio is automatically muted. If you have any questions during the webinar, please send those questions to Mark or Todd using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate at the very top of the WebEx menu and choose Audio Broadcast. If that doesn't fix things, look in the Participant window where your name is located, and at the bottom left, there's an icon. That looks like a little phone. If you click that phone icon, you'll disconnect from the audio broadcast, and it'll give you information that will allow you to join using your phone, which should clear up any potential audio issues. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the webinar. Once that recording is available in a few days, we'd love for you to follow along with your handheld or your software. Doing that tonight on the fly, I think is going to be really challenging to do, especially with a lot of the coding that Todd and Mark are going to be doing. It's going to be, I think, a lot easier and more effective for you once that recording is available again in a couple of days in your email. Download that recording, grab your handheld or your software, and that way you can go at your own pace. You can pause and rewind the recording as necessary. At this point, Todd is going to discuss our agenda.
Okay, so we already have gone through the welcome and introductions for tonight. The main topics that are up there is hopefully what we'll be able to get through in the hour here tonight. Basic coding, we're going to do some live coding and also some video recordings of what we've done. We can show you the code on the screen, but unfortunately we can't show the Innovator. So we recorded the Innovator doing some of the work and have videos embedded in the presentation for you to watch and see what the code that's being written is able to do with the Innovator. Throughout, we're going to talk about STEM connections with the Innovator Hub. So it's not just about how to write code, but also then how this code can be used in math and science and engineering courses to help students explore or better understand different concepts. Finally, we'll talk about the Innovator Hub itself and how it's being used in different STEM courses and STEM camps, from small events with GEMS to larger events being hosted at a university in Missouri. There's some online resources we'll be able to show you along the way as well, and then I believe Mike at the end will have a webinar giveaway for one lucky participant here tonight.
Thanks so much, Todd. And Mark is going to discuss our expected outcomes.
Yes, so there is so much to learn about coding, and so we're going to point you in the direction of the TI Codes website in a moment. But you will get to see some of this coding in action. So we'll try to talk through about how we can use TI technology as a basis for learning to code. And it's really a lot more about the thinking that goes into coding that we will be highlighting. I see a question about will there be any coding for the TI-84 family, and my answer is I will be showing a little bit of the 84, and a lot of but most of our coding will be on the Nspire, but a lot of the syntax in talking to the Innovator is extremely identical. There'll just be one subtle difference that I will point out. So we're going to look at how we can use not just coding, but connecting with the TI Innovator Hub and the LaunchPad board to see what are the interesting things we can do with STEM.
Thanks so much. Todd, you have control. Go ahead and share your desktop.
Okay. This is the first one of these that I've been sharing things with, so hopefully it goes well and everything turns out as we want it to turn out. So I'm going to take the first few slides and talk through some information, then Mark's going to jump in for a while, and then we'll kind of go back and forth here some. I'm going to share this with you here. So obviously the purpose of tonight is talking about TI coding and the applications of coding using the Nspire CX, the 84 CE, and the Innovator Hub with both of those two. As Mark talked about, we're mainly going to focus on the Nspire tonight, but it's very similar to go between the Nspire and the 84 CE, and most of the documents that are created online have the coding directions for how to use both platforms as you go through. So TI Codes is a new major initiative that TI has come out with, but why is it important? Well, here's some recent research. 7 million job openings in 2015 were in occupations that required coding skills, and programming jobs overall are growing 12% faster than the market average. So as our kids are leaving our high schools and going to college, this is one of the fundamental skills that they will need moving forward. And when they were doing the research, the Burning Glass job analytics firm for this, they looked in a variety of areas: information technology, data analysts, engineers, scientists, but this one I thought was great with the artists and designers. I don't know that our art classes necessarily consider coding and how it can be brought in, but it's a pretty major area where there's a lot of coding that goes on, obviously, with animation and online designing and computer graphics and all types of areas. And in fact, one of the community college here that my high school feeds into started last year a 2-year certification program for developing apps for mobile devices. And the students that go there, they decide if they want to go into the Microsoft, into the Google or the Apple platform, and they learn how to create apps over the 2 years that they're there. Their last semester, they're paired up with a graphic design student, and the one student writes the code, the other student does the artwork behind that, and then they publish their app when they're done. And they have the certification when they're done with their 2 years to be able to jump into a job. And the last I heard in Chicago, there were hundreds of jobs open for mobile apps, where the starting pay was around 50 to 60,000 and getting up to 100,000 within a couple of years. So obviously some really powerful jobs that can be created out there if students understand how to program. Most of the jobs are coming from openings in finance, manufacturing, and healthcare, but there's a variety of different areas that they're coming from. But jobs that require coding skills pay up to $22,000 more per year on average, and nearly half of all jobs that pay more than $58,000 per year require some coding skills. That kind of information usually resonates with students. So as you start talking about what you're doing here will lead to money and jobs for you. That usually is a pretty good motivator for them. Over on the right are a variety of different programming languages and coding concepts that the current workforce is looking for, from databases, web development, to general purpose programming. There's a lot of languages that are on there. The Nspire CX and the 84 plus CE, the language that we're going to be going through tonight, is TI Basic. But once you learn one language, it's much easier to transfer from one language to another. So learning TI Basic will help students down the road understand how to pick up any of those other languages that are listed there. And one of the topics I presented on in Chicago was on how to use this platform with the AP Computer Science Principles course. You can use any language that can be used to code and then produce artifacts, and you'll see tonight some of the artifacts that can be used, and this is a great platform to use, especially for students who already have the Inspires or the CEs. There's no other technology necessarily you need to buy beyond the hub and maybe some of the peripherals for it. So it's a powerful device to use as an introduction to coding, but really what you can do with it is limited by your imagination. Mark, I'm going to stop sharing and send it over to you.
Okay. Just waiting for you to send it to me.
No, go ahead and share from your screen, from the WebEx.
The globe is still on your name.
Now you got it.
Here we go. Here we go. Okay. So I'd like to talk about the TI code site a moment, but just before I do, because we'll be looking at the TI Innovator Hub, and what is it? So I'm just going to go to a picture of it here. This is what the hub looks like. I know on the screen it might look huge, but it's actually, I don't know, it's about 2 by 5 inches or so. And this is a device. Texas Instruments is a lot more than just a calculator manufacturer. Actually, most of their industry is with semiconductors and those kinds of technologies. But this is the kind of thing that people use all over the world, not just with Texas Instruments, to prototype things and try them out. And so what Texas Instruments has done is brought this amazing technology to the classroom. What it has when you get it, it has a built-in light, which we'll be coding with first. There's also an LED light, which has both the red, green, and blue parts to it. And there's also a speaker, so you can generate sound. You'll notice in this bottom left-hand corner here that there is a brightness sensor. And so the idea here is it's an interface that we can either send information to get it to output certain things, or we can read some information in. So if you think about the science devices from the past, those were all data collection types of devices, which were just about collecting input. This allows both input and output. In addition to all of the built-in devices, it also has ports on the side as well as a breadboard, so you can really connect almost any kind of sensor or output device to it. So it just opens up a whole world of possibilities. Because this TI code site exists, we're not going to go into too many details. I do invite you to take the time to go back and look at these courses. If you're interested in just coding in general on the 84 or the Inspire, you can go here. We'll be focusing on coding with the TI Innovator Hub. And the way this is designed, you choose your device. So I'm just going to choose Inspire. And it's broken down into 3 main units. And the idea here is it's going to go through some coding structures and at the same time introduce the TI Innovator Hub. As a teacher, for example, if I go to this Getting Started, you will notice this little tab here called Teacher Notes. And that will have both a student handout, some teacher notes, as well as any programs or TNS files that you may need to do that with. So that's definitely a place to go when you have some time. Each lesson is designed to take about 10 minutes. It's a very worthwhile way of slowly getting a sense of how to code and how to talk to the innovator. So speaking of talking to the innovator, I'm going to now show you how we do that. I'm going to start with the Inspire, and then I will switch over to the 84. So right now, I know you can't see it, but I have a TI Innovator Hub connected to my computer. It can also connect to a handheld. And right on a calculator page, I can send it a command. and it literally is send. We use the word send to send something to the innovator. The way it works is I put here a string, and what happens is the innovator will interpret that string and then figure out what is it I am trying to tell it to do. So if I do something like set light on, I know you can't see it, but right now as I look at my innovator, there's this red light that is staring at me. So I'm going to now turn it off, and the light goes off. Other parameters that I can do is I can determine how long it stays on for. So I might say set light on for a time of 2 seconds, and then the light will come on and then go off after 2 seconds. So this is a good way of introducing, if you are using the TI-Nspire, it's a good way of introducing sending commands to the hub. I've done workshops with teachers using the Innovator, and the reaction that they get when they talk to this little box and a light comes on is generally a wave of cheers, because they got it to do something. But most of the time, we are going to talk to the Innovator and read from the Innovator through a program. So I'll show you how to set up a simple program, and then I will show you how to do the same thing on the TI-84. So under the, if I insert a page, notice now in the latest OS, we have the program editor becomes one of those options. And so I'm going to select new. And I will give it a name. I will call this light. We won't get into the distinction right now between program and function, but when we're talking to the Innovator, we're going to be using a program. So now this is just like what I had on the calculator page. I can now send a command to the TI Innovator. The other feature that is important to know, though, and this is very handy, is that the menu now has a hub access. So when I'm in my menu, I can select hub, and then we have all of these different things. This is the safest way to go, because then, oh, I'm just going to exit out of there. Then you can be sure to get the syntax correct, because if you don't get the syntax correct, it won't work. So right now I want to talk to the light, so I'm going to say send set. Notice there's also a read. That is if it's an input device, and Todd will talk about that later. So send set. Look at all these different things that I can set in terms of outputs. There's the light, the different colors, sound, speaker, buzzer, relay. There's all kinds of these different things, and it got a little bit ahead of me there. I'll just go back because I want to send to the light. I could have typed this the way I did on a calculator page, but it's a good practice to use the menu. Even the word on, I can get from the menu under settings. That's where I see things like on and off, the time, and so on. So I want to set the light on, and then I want it to go for just 2 seconds. So this program will now do that every time I execute the program. It'll set the light on for 2 seconds. But before the program will save. On the 84, programs save automatically. On the TI-Nspire, I have to check syntax and store, which is the shortcut is Control-V or Command-V on a Mac. I go back to the calculator page. When I go to the var button, I see the program light, and when I execute it, the light comes on for 2 seconds. I will now show this on the 84, and just so you're wondering, gosh, am I going to be watching him live code all night? We'll do a little bit of this kind of live coding so you see how it unfolds, but then we will show you existing programs to save us some time. So over on the 84, now I'm going to show this using the TI SmartView software, which at the moment does not talk to the Innovator directly. But if I were to be connected with a TI-84 handheld, then I could. But note that it does need to be the CE model. So in a very similar way, I create a program. So I press the program button. I'm going to say new, and I'm going to call it light. Now I'm in this program called light, and if you have the latest operating system and you load an app that is called Hub, so I'm just going to go to my Explorer here a moment, just so you can see that you need to have load in an app called Hub. It doesn't appear in the apps menu. This might take too long to be worth it. Anyway, oh, there we go. So down in my apps, we will see that I have an application called Hub. So that's something you need to load into the calculator to have access to the Innovator menu. So to access that menu, I push Program. Over on the far right is the Hub menu, and it reads just like it does on the Nspire. So I select Send Set, choose Light, and then I can type the word on, or I can get it from the Hub menu. So notice the one difference between the 84 and the Nspire is this open parentheses. On the Nspire, the command to an Innovator is done with a space, but on the 84, it needs to be a parentheses. Because this is a string, I need to close off the string with quotes and then a close parenthesis. Somebody asked if the spacing, yes?
Sorry to interrupt. Diane just had a quick question. Is the spacing required for the code?
This extra space is not required. Because it is expecting that I might be typing in a number, it puts that space in there. But I could remove that space and remove this space, and it will work just fine. It does obviously need to have spaces between the words. So this program is now ready to run. I just quit here. I go to my program menu. It was all the way down my menu, so I'm going to go Alpha L, so it jumps down to the L part of my program thing, and then I can execute the program light. You don't need the Innovator to code. You can do all kinds of writing with programs without the Innovator. This idea of the kind of coding and the commands we're showing tonight is specifically for the Innovator. You can still write the programs, but it's you need to be able to have the Innovator to see what effect those programs have. But there's all kinds of coding that you can do without involving the TI Innovator. A little tip, if you are going to be doing some coding on the 84, is if I use the TI Connect software, here is, I'll be explaining this program in a moment. Here is, you can execute or type in programs directly in this interface, and what's nice is there's a little Send to Connected Calculators button, and so it's very easy to then code on a computer and send it to a handheld. So I now want us to consider a question. I'm going to go back to the Nspire for this. Let's say, because just turning a light on and then off again is not very exciting, although it can be the first time you turn that light on. But let's consider about making the light blink. And let's say I want to make the light blink twice a second for 5 seconds. So just so we have an idea of what I'm wanting to do here, I'll just add a little notes page here. And I'll just say, how can we make the light blink twice a second for 5 seconds? So I invite you to just think a moment about the mathematics that would be involved in this. With the coding, I can tell it to turn the light on for a particular duration of time. How many times will it blink altogether if it's twice a second for 5 seconds? There's a rate kind of problem that students can consider. But also, what should I set that time length to be? So if I want, let's consider one instance of the light coming on. It's 5 seconds, but in each second, I want it to go on, off, on, off. So there are 4 periods within that single second. So that time length will be a quarter of a second. Then I want, after that time, it'll automatically turn off. So I don't actually need a set light off command, but I need some way of telling it when is it going to turn the light back on again. We have this command called wait. And this is a very important command when coding on the Innovator, because in a program, the calculator will just run through steps and it won't finish. So if, for example, if I just did another send command, if I just did that, it would completely ignore, it would completely jump past that first one and go to the second one, because the calculator is thinking, I'm running a program, I'll go from one step to the next. So in order to provide a break, we can use a wait statement. So if we think about this, and again, this is a lot of mathematical thinking. When I set that light on for a quarter of a second, when do I want it to come back on again? If I wait half a second, then it'll be on for a quarter of a second, off for a quarter of a second, and now back on again. So I can do this 10 times. I will show you a couple of alternatives that will be a lot more efficient than this. But let me just quickly show you a video of what it looks like once I run this completed program. So first of all, here's what that completed program looks like. So we have the set light on, time for a quarter of a second, and wait for half a second. And here's the result. My finger is pointing to where the light will appear on the hub. I go to the var menu to bring up the program, which I have called blink. And when I run it, because of the lag, you may not see it flash 10 times, but I assure you that it flashed 10 times. So that is one way that we could tell it to blink twice a second for 5 seconds. And the reason I showed you that way was to help just introduce the thinking that would go into making that happen. Now, as it turns out, and by the way, we will be sharing this file with you. We have a file that we'll be sharing with you called Innovator Webinar for this date, and all of these programs already exist. And we'll also be sharing with you TI-84 versions of these same programs in case you want to see what it looks like on the 84 or try it with the 84. So here's that first version of the program. But there's actually a built-in way of doing this in one line of code. And it looks like this. There is a blink command. And the blink command is about frequency. So blink 2 means a frequency of 2, where frequency is times per second. So this command will tell it to blink twice a second for 5 seconds. But I want us to consider a third option, and I saw somebody wrote a comment about it as well. This is nice that the blink is an option in the set light command, but also from a coding perspective, it's nice to think about how do we avoid having to write out step after step after step when it's repetitive. And this is the power of a loop. So in this third version of the program, I've set up a loop to go through this 10 times. Just to set the light on for 1/4 of a second, wait 1/2 a second. And so this, for n from 1 to 10, what it will do is it'll give n a value of 1, execute the program, then add 1 to the value of n, so it'll go n equals 2, and so it goes on and it goes through those 10 loops. So it's a very elegant, programming introduces elegant ways of being able to describe instructions. Because that's what we're doing when we're coding. We are giving instructions, be they calculations, commands, and so on. And so as we get more comfortable with coding, we look for these ways of making it more efficient and elegant.
Hey, Mark. We had a question from one of the attendees about, can you put comments into the code? Can you show how to insert a comment?
Yes. So I'll just put a line here, and under the menu, Actions, there's an option here to insert comment. And I could say something like, this program will make the light blink 10 times, or something like that. And so the calculator knows to skip that line of the program. The 84 does not have a comment feature directly, but what it does have, I'll just edit my light program again. What we can do with this one, if I wanted to put in a comment, is I can just put it inside of a string. So if I go alpha and then quote, I could then type a comment, which is very tedious in the emulator here. So this, etc. I can type a comment there, and the calculator will just skip it because you're not telling the program to do anything. All right, before we leave Blink, I'd like us to consider a fourth thing, and that is, let's go back to our slides here. The idea of changing the frequency. So I'm going to just show you, this is Todd's video here, and we'll see some familiar code at the beginning, similar to what I just did with Blink, but he's going to now change the frequency and we'll see the effect. Notice his use of 1 and 0. So the innovator understands binary language. Instead of on, you can use a 1, and instead of off, you can use a 0. So right now, his program is set to blink twice a second for 5 seconds. And he also had that opening part just to turn the light on for a bit so that you know to expect the blinking to come. And now he's pointing to the blinking. But now he can change the frequency and observe the effects. So with learners, it could be, I would want to give them the prompt, change the number, what do you think will happen, then try it and see what happens. And if it's what they're expecting, that's a confirmation. And if it wasn't what they were expecting, that's a good learning opportunity for them to think about why not. So let's consider these extension prompts. What if we wanted to generalize the program where you could actually input the frequency and time? Instead of having to do it right within the program, we can make it part of the user experience. And then from there, might give students a challenge of, well, what are 3 ways to make the light blink 20 times? And what thinking went into doing that? So rather than do the coding, I will just show you the coding. It's part of the file that we will be sharing. So on the Nspire, we can use this request command. How many times per second, and define it as with a variable f, and then how many seconds, and define it with a variable t. I could have also put parameters in the parentheses of the program name and done it that way instead. But I like to use the request command so I can give language. on the TI-84, we would use the input command to do a very similar thing. But notice here in the Nspire coding, or the coding on the Innovator part, because it's part of a string, I can't just say blink F, because the Innovator will just read that as the letter F. It does not know that it is a variable representing a value. So we have this eval command, which is available through the programming menu. Notice there, number 6 is eval. We have this eval command, and what that tells the Innovator is, don't read that as the letter F, read that as the value that is stored into the variable F. So we blink for evaluating the frequency and do it for the length of time. So that's a way we could generalize this program. So that is some extra things that we can do with just with the light things. There are lots of possible other uses, and I encourage you to, challenge your thinking of what are you doing in mathematics that you could make use of just this simple coding to make a light turn on or off again. You could do light patterns. There's all kinds of things that you might want to do that connect with your mathematical class as well as your science class. And so that's just the light. We're now going to explore the light, the color RGB LED light. And to do that, I'm going to pass it back over to Todd.
All right. So let me jump back into, uh-oh, my Chrome went away. Hang on one second. Mark, we may have to have you continue with the presentation, and I'll just talk through it because my Chrome has disappeared and I can't seem to get back into it.
Okay.
All right, so I'm going to pass it back to you. So go back to the presentation, and then I'll just talk through the presentation as it's going through.
Okay, I will be your Vanna and do the clicking.
Thank you. I was telling Stacy earlier that I'm typically your Vanna because you are so much more intelligent at all of this than I am. But we'll go for it this way. We'll reverse roles for once. Okay, so far all we've done is there's the one color LED that we have turned on, but there's also a 3-color LED that's in here that can do the red, the green, and the blue. And red, green, and blue being 3 primary colors of light, you can now mix and match all the different hues of light that are possible. So this one that I'm going to show you here is it's using loops. It's going through all of the different, adding just red and green and blue and taking away. So we're doing color addition and color subtraction, which is great for any kind of an art class or for a physics class, for example. And then from here, you'll see how we have loops that move the color forward and loops that take away in certain steps as you go through. So Mark, if you want to go ahead and play the video. As it's going through, I'll talk through the code. You'll see my pointer go across. There's a text box that will open when the program runs, and it will have those requests, like Mark was just showing you, for the wait time between the steps and how big the steps should be. So Mark, if you can pause for a second. So the steps are the increments between our parameters, and the parameters are 0 to 255. This uses an 8-bit binary system. 256 would be the value of 2 to the 8th. So 0 is dark, and then 255 would be 256 digits greater than that. So that's what the range will be, and that's the brightness of the bulb. So 0 would be off, 255 would be the brightest that the LED can get to. So within the loops, we are going to ask for how long should we wait before we get to the next incrementally brighter light, and then what value do you want that to go up by? If you go up by a step of 1, well, then this is going to go through 255 iterations, 0, 1, 2, 3, all the way up. In the video, I'll show you that you can do 25, 50, however you want it, and it makes the increments go much faster as you go through. So Mark, go ahead and play it. The first loop here is using the set color instead of the set light. That's the command for the color. And if you notice, there's 3 there. There's eval I 0, 0. That's for red, green, and blue. As we move forward, go ahead and stop this, Mark. The first one, I had set color eval I in the first blank for the red. We're going to evaluate the value that we're going to use for the red color until it gets to 255. And then a text box is going to open on the screen that says, enjoy the red. Now we're going to get to our next loop. And what we're going to do with this loop is we're going to leave the red on. That's why it's set color 255. But now we're going to do that evaluation string for the green color. So now with the red, we're going to add the green in. We're leaving the blue off, and that's why that's set to 0. So go ahead, Mark. Now as we move through for this one, you'll see that it's backwards. Go ahead and pause it. We go from 255 to 0 now, because what we're going to do is reverse the steps. So you'll see the negative S, and we're going to leave the red light on. I'm sorry, we're going to leave the green light on, but now we're evaluating going backwards with the red from the 255 back down to 0. So we started with the red, we added in the green to get yellow. Now we're taking out the red to get to the green. So this would be a reverse loop, if that's the right term, to go backwards instead of forwards, to decrease the value rather than increase the value. Please go ahead. At the end of each of these, you'll see a text box goes on. And so this code continues on through to add and subtract all the different colors as you move. So here we are taking away the red to just have the green. Now we are going to have the red off, have the green on, but now we're going to have the blue increase incrementally until we have green plus blue, which is cyan. Now we're going to take away the green from the cyan. So we have the negative, starting 255 to 0. Go back to the blue. Somebody just talked about the Arduino. It is very similar. It's the Arduino for the TI platform is a lot of ways that people think of this. Now we're going to add the red back into the blue so we get the beautiful magenta color. Again, that's increasing. And then finally, we are going to take away the blue to get back to just the red that we started with. So here we're evaluating the blue moving backwards with the red on, no green. Now we're going to subtract the red out, and then one last command to set the color off. So there's lots of steps through there, lots of for loops, but increasing, decreasing. We save the program, we go to our calculator screen, we run it, and now you'll see the innovator go through this with the text box commands. So a short wait time with fairly large steps, and now it's going to run the program where my finger is. The red incrementally increased, turns into yellow, so on and so forth. All right, so there's that command and that program. Mark, I'm going to go ahead and take back over for a second. Sorry for all this jumping back and forth here. And hopefully this will work now. All right, share my screen. Okay, so in this program, this was when somebody had put the comment in there about how to put comments. But you don't need, as Mark was showing with the light, you need to write a whole program for this. It depends on your goal in the classroom. And if your goal in the classroom is to teach kids how to code, then that would be a great program to do and go through all the coding iterations. If you just want to do the colors and what they are, then you can do, instead of send set light, you can do send set color, and you can put in the commands here. So when I run this and it's connected to the innovator, I now have a very bright red light. If I do this same command, but I change the 255 to 100, I have a less bright red light. If I change the colors again, and I have, say, 100 red, 0 green, 100 blue, I now have a not so bright magenta color. So now as you're going through here, you can have challenges for kids of, okay, instead of just the cyan, the magenta, the yellow you get, how can you make white? How can you make other colors such as orange? Make your favorite color. Then you can start getting into concepts in the math course such as proportions, and what's the ratio then of red to green to get to this color. You can, if you're in a chemistry class, you talk about mixtures. It's a great way to get into mixtures and how the different values impact each other. So a lot you can do with a very simple program, and based on what your goal is in the classroom is how much of the coding you build in, or do you go straight to a simple program like this where it's not so much teaching coding, but it's the application of the coding. All right, Mark, I'm going to stop sharing. If you could go back to the presentation then. And Ashley, you're right. Kids do love coming up with these. I went into a middle school in inner city Chicago, and I was doing this with the middle school students, and some of the kids were having a difficult time just following along. Other kids were flying through this, and they were so excited. I just made this color. I just made that color. And they were challenging each other to take colors. I just sat back and let them run with it because they were so excited to be able to do this fairly simple task, but then challenging each other to, now you make this color, now see if you can make this brighter or dimmer. It was awesome just to sit and watch them do this and be excited about the learning and coding as they're doing it, and now you're adding in the color addition, subtraction, the proportions, all that into it. It was great to watch them mess around with this and have fun just through playing and learning as well. Mark, if you can present again. So that's one we just did. Okay, so Mark showed in the picture before the brightness sensor. In order to do this, I'm in my office at work, and I had to borrow a friend of mine's iPhone, so I was recording this on my iPhone, and then I was using his iPhone flashlight with the lights off in my office. My people in my office watching me thought I was crazy, but what we're doing with this here is using the brightness sensor, and we are reading the brightness of the light. And so I'll run through the code for how to do this first, and then I'll show you a future application. Somebody before had mentioned, wouldn't it be cool to turn this into a graphing activity? Well, I'm going to turn this into a graphing activity, and you'll see in the second video for this. But Mark, go ahead, and we'll show the code for this one. So this is the first time for a couple of commands in here. So Mark, if you want to pause this. The first thing is the display code. The last one had a text code where it opened up a text box. The display will show off on the right-hand side where the answer would display light sensor. So it's not a text box that you'd have to click out of. It just shows up on the screen for that. And instead of using a for loop now, we're using a while loop. And so it's a different kind of loop that's built in to the hub, and it's a different way of going through the programming with them. So whenever you're using a while loop, you are setting that the Innovator will run, or the program will run, when values are in a certain range. So the first thing you have to do is set the initial condition. The brightness, the Innovator knows that when you're using the letter B, that is going to be doing something with brightness once that brightness command has been put in. So we originally set the brightness to be 2 because we want the initial condition to be greater than what the while loop will be using. So the initial condition then in the while loop is that while the brightness that we're going to be reading is greater than 0.25, the program's going to run. If we set the initial condition to be 0.1, and then while the B is greater than 0.25, the program would never kick in. So you have to make sure you set that parameter. What we've been doing so far then is send set, and we are telling the hub to turn something on or do something. Now we are telling it to read the brightness. So it's going to take the brightness sensor and pull information in. So now instead of having an output, we're going to get an input. We have to tell it to get that input. And then the next command that's on there, the display command, Mark, go ahead and play this. The display command is now so that the values that we are getting will show on the screen, and we are going to get values every half a second. So every half a second, a value will show up until the brightness is less than that 0.25. So I didn't do the greatest job. It's not the most scientific experiment here, but the flashlight is on, and now as I bring it closer, you can see that as the light is getting closer, the values are increasing. And I'll show you the application of this. I kind of missed the sensor there at the bottom and took it away. And once the values got below 0.25, then the loop stopped. So there's the program running to get that information. So Mark, if you can show the next one now. You're great, Vanna. So now it's the same program, a little different data that's coming in, a little fewer data points. But what I'm doing here is the same exact experiment. This is a screencast to capture the data. And you can see where I stopped having the light over at the 46.9. What I'm going to do now is simply copy that data for when I was bringing the light closer, and I already created a spreadsheet. So Mark, if you want to pause this for a second. This would be something that could already be created for students, a TNS file that you could send them. And so now we are copying the data that we got, that display, and now what we're doing is we're putting that data into a spreadsheet. Again, not the most scientific, because you'll see in a second that I don't put actual distance values in, but what I do is I recognize that I have 8 data points that I put in here, so I'm going to make my furthest away data point 8, and then my closest data point 1 as the distance was decreasing on the way. So go ahead and play it. Then I created a data and stats page on the next slide here, and so now what you can do is look at the relationship from brightness to distance. And when you do a power regression, that data is now showing the inverse squared relationship between brightness and distance. So now you can talk about, Mark, can you go back to that, the end of that? You can just scrub over to it. But you can do this with any of the data that you collect. And if you're running this in a physical science course where you're getting this idea across to students about the inverse squared relationship, well, now you can bring in, this is a great time, if you're familiar with the curve of remembering, to help students go back and retouch on things, and it becomes more ingrained in their heads, and it builds retention. Now you can not only talk about the brightness-distance relationship and that inverse squared, but now you can get into Coulomb's law if you've taught about that, or it's an introduction to that later on, universal gravitation, anywhere you have that inverse squared relationship. This is just one of them. I've seen this done with a sine graph. I've seen it with a variety of different graphs where you're collecting the data, and then now you're using it to do some graphical analysis with it. All right, Mark, thanks. And back to you.
Okay, so we're actually just out of time, so I'm going to go very quickly through some last thing. There's a lot of other cool things that we can do, even with just the Innovator as it is. One of the things I did today before starting was I programmed a sound to follow a function. So if I change the function to x squared, then it would play a high pitch, come down to a low pitch, then go back up to a high pitch. So you could actually hear what functions sound like. By connecting or using more than one device at a time. So there's no reason why in a single program you can't read from the brightness sensor and output through a speaker, the light, and so on. And this whole idea of STEAM as well integrates art and so on. So very, very quickly, just this is from a STEAM camp that was coordinated by Ann Schlemper in Columbia, Missouri. And some of the things that they did, just to give you an idea of some of the possibilities. This is a pet protector. It's about when it gets too hot, it rolls the windows down. And so there are lights here that flash once the temperature gets too hot. There's a sensor to indicate when the pet is inside the car. And once the temperature reaches a certain height, then the windows automatically roll down. So there's a lot of things interacting there as it goes along. There's a mood ring thing that is reading something from their finger and converting it to a color, solar tracker, and so on. So there's just a lot of really cool other things that open up some possibilities. Robotics is going to be a new thing that we'll be seeing a lot more from this year. So when we think about STEAM or even just STEM, all of these different parts really come together so nicely in an authentic, integrated way when we're coding for the Innovator. So I am going to, oh, and here's even some art. We're going to put some lights on some wire string and make some artistic designs. Anyways, I'm going to stop sharing so that Mike can take over and close us out.
Thanks so much, Mark and Todd. As we begin wrapping things up tonight, if you have any last-minute questions for Mark or Todd, please feel free to get those asked. You guys have been asking some great questions tonight. I know they'll do their best to get those questions answered before we end. I do want to share a few resources that are available on our website, education.ti.com. Earlier, someone had asked how much the TI Innovator costs, and not just for the Innovator, but for any of our products. If you go on the right-hand side, where to buy, that's a great place to get connected with our educational dealers to get really specific pricing for our products. So please feel free to check that out. And then also under the Professional Development tab, if you go under Register for Workshops, we're really excited that this summer we're going to be offering over 50 different summer professional development workshops across the United States. And if I sort this by title, you can see how many of those are involving STEM and the TI Innovator Hub. I noticed a few people on site said they were going to be possibly taking some professional development this summer with coding, and maybe that was with us, I'm not sure. But we are offering a lot of coding summer professional development. These workshops are usually either 1, 2, or 3 days. They come equipped with technology. I can't say enough about them. It's whenever I was a non-T-Cubed instructor, it was the best professional development I had ever attended because I really had the opportunity to actually sit down with the technology with someone that really knew it really well and other teachers that were like-minded in the same area that I was teaching. I got a chance to talk to them and, again, experience this technology, take it home with me, and it was a really amazing experience. So please feel free to visit our website to learn more about the T-Cube summer workshops. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we really hope you share your thoughts in the post-webinar survey. As I mentioned a few moments ago, we do have a lot of summer professional development workshops that are being offered. And as Todd mentioned at the very beginning tonight, to one lucky winner, we're offering a free registration for one of those professional development workshops. And tonight's lucky winner is Katrina Tunstall. So Katrina, congratulations. We really hope to see you as well as everyone else at a T-Cubed summer workshop. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents that were used tonight as promised earlier by Todd and Mark. And one of the nice things that Todd and Mark did is they included all the coding files that you might need for the TI-Nspire as well as for the TI-84. So regardless of what technology you're using, those files should come in handy. And if you happen to miss those links or they're not working for you tonight, have no fear, you'll automatically get a follow-up email in a couple days. And in that follow-up email, as I mentioned earlier, will be a link to the recording, as well as a link to the certificate and a link to the documents. And if you're watching this on demand, please feel free to copy that link into your favorite browser to receive your certificate. And after the webinar, if you have any post-webinar questions, feel free to give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. Thanks so much, Todd and Mark, for everything you shared tonight. Like I mentioned earlier, I thought there were some great questions asked and some very engaged participants. So thanks so much for everything you shared tonight.
It was a pleasure, and we're just getting started.
Thanks, everybody. Have fun with this.
Thanks again, everyone, and we hope to see you back online next week. Have a great night.